Hi, everybody. We are going to be chatting about 3.7. In 3.7, we've got all of our derivative rules pretty much. There's still, some kind of small rules here and there. We're going to see a few more, for instance, down in 3.11 for some different kind of functions, the hyperbolics. But, with logarithms, with general exponentials, with the chain rule, trig derivatives, we even had the inverse trig derivatives, products and quotients, polynomials and exponentials going all the way to the top. We pretty much have everything to go forward. So let's take a look at the rate of change applications. We're going to kind of pause here and just see lots of different applications of derivatives and maybe even second derivatives for lots of different types of functions. So one thing to keep in mind, position, velocity, and acceleration that we saw before. Velocity is the derivative of position. Acceleration is the derivative of velocity, or you might say the second derivative of position. All this lecture is going to be is just walking through a few different types of examples, kind of give you a feel for how these work and how to approach these different types. So here we go. Let's just jump right into this one. A particle moves along a straight line with the position given by s of t equals negative sine pi t over 4. So we've got this particle. It's just moving back and forth along a straight line. So sometimes it moves to the right, sometimes it moves to the left, right? And there'll be some kind of like a wave pattern because its position is defined by sine, negative sine. S is in meters, T is in seconds. Okay, so we're going to look at the particle's velocity, when it's at rest, over what intervals is it moving in the positive direction, and its acceleration. Let me go ahead and switch. All right, here we go. So S of t was equal to negative sine pi t over 4. And part A was, what's the velocity at 3 seconds? Right, it's a little bit better. Well, for velocity, of course, we need a derivative. So I'm just going to call it v of t, and we'll know we're taking a derivative. So, okay, derivative of negative sine pi t over 4. Well, we're going to have a chain rule with sine on the outside. We also have this negative. This negative is a constant multiple, so that's just going to carry down. Then our chain rule says take the derivative of the sine, that's cosine. Then we'll copy what's inside of that. Then we'll multiply. Multiplying by the derivative of pi t over 4. Here's how you can think of things like this. Think of pi t over 4 as like pi over 4 times t. So we've got a constant times just our variable t. Looking at it this way, the derivative is simply pi over 4. You could approach it like this and do a quotient rule if you really wanted to. Be careful if you do that, but it will result in pi over 4 as well. But a little bit easier thinking of it this way, and just, oh, well, it's the constant. Okay, so then v of t is negative pi over 4 cosine pi t over 4, like that. If we want the velocity at 3 seconds, we'll say, okay, well, let's plug in 3, negative pi over 4 cosine 3 pi over 4, and we'll grab our calculator, sure, in radians. Let's see here, negative pi over 4 cosine 3 pi over 4. Let me just do, let me answer with pi's in it so I don't have to round. What's the cosine of 3 pi over 4? So this is negative root 2 over 2. If we multiply that by negative pi over 4, we'd get positive pi root 2 over 8. And that looks pretty good. What are the units here? We were told, I didn't write it again, but we were told it's meters and seconds. So this velocity is meters per second. Like that. Okay. Let's move on to part B. Part B was at what time or times is the particle at rest? So we're thinking, it's moving along the straight line. Sometimes it's moving right. Sometimes it's moving left. We can even see it here at 3 seconds. It's moving in the positive direction. So we could think of it as moving to the right, if it's like a number line. When is it at rest? The particle would be at rest when the velocity is equal to 0. So how can we approach this? We'll take our derivative, take our velocity function, set it equal to 0 and solve. We know that this is negative pi over 4 cosine pi t over 4. When is that velocity 0? Think, okay, well, this negative pi over 4, we can divide that from each side and left with cosine, just cosine pi t over 4 equals 0. We say, okay, what angles is the cosine equal to 0? This would happen, let's see, when is the first time that cosine equals 0? So it starts at 1, it comes down to 0 at pi over 2. So when that angle is pi over 2, then we know that cosine is going to equal 0. So if this whole thing comes out to equal pi over 2, what value of t would do that, right? We know we get cosine of 0. It occurs again at 3 pi over 2. So we can solve both of these. That's just for the first period, which I didn't copy over in the very beginning. But they said this is where t is between 0 and 8, between 0 and 8 seconds. Let's solve these. We'll need to find all of the solutions for t where t is between 0 and 8. But I think just these two is going to do it here, just one period. Let's see here, if we divide by pi, multiply by 2, t would equal 2. And if we set it equal to 3 pi over 2, kind of same idea, divide by pi, multiply by 2, we get t equals 6. Okay. I think if we were to continue with solutions, our next one would probably be at 10, spaced out by 4 seconds. And so we can stop right there. So at these two moments, t equals 2 and t equals 6, the velocity is equal to 0. All right, keep going. Part C. This asks for the interval or intervals where the particle is moving in the positive direction. This is interesting. Where's our particle moving in the positive direction? So if we thought, well, that'd be when the velocity is positive, greater than 0. We know that it's equal to 0 at 2 and at 6. And it turns out that's going to be really helpful for us. Let's think of a timeline from 0 seconds to 8 seconds. And I'm going to mark off 2 seconds and 6, because I know that's when the velocity equals 0. You think, well, if these are the only two times where it equals 0, then it's probably changing direction. So it's going in a particular direction for the first 2 seconds. Then it's gonna stop, slow down, stop, and then start moving in the other direction for the next 4 seconds. Then it comes to a stop again, and then again begins moving in the other direction for the last 2 seconds. So here's what we can do. Test a value from each interval in our velocity function. Let's just take a number from each one of these 3 intervals, plug it in, and see what happens. When is it positive? When is it negative? So I think a good test value here would probably be at 1. Maybe here we could, we could pick 4, we could pick 3, right? And maybe 7. So let's find what is the velocity at 1 second. Okay, so that'd be negative pi over 4 cosine pi times 1 over 4. Let's see. Well, the cosine of pi over 4 is positive root 2 over 2. So root 2 over 2 times negative pi over 4 would be negative root, let me write the pi first, negative pi root 2 over 8. So that is going in the negative direction. Okay. So I'm going to say it's moving in the negative direction, maybe something like that. For the first 2 seconds, the particle, like if it starts maybe at the origin, then it's moving to the left. But then at 2 seconds, it's going to slow down, come to a stop. What's happening at 4 seconds? Well, for the velocity, we can plug in. Now, if we plug in 4 for t, it's going to cancel. Let's see, cosine of pi is negative 1. So this comes out to pi over 4. The value itself really isn't important. It's just, is it positive or negative, right? So here it's a positive. So it starts moving back to the left. If we thought of like starts at the origin for the first 2 seconds, it's moving this way. Then it slows down, comes to a stop. Then it's going to start heading back the other way. At 6 seconds, it slows, comes to a stop. And finally, I'm imagining it's probably going to start moving back in the other direction. 7 pi over 4. Let's see, what's the cosine of 7 pi over 4? Positive root 2 over 2, the same as pi over 4. You get the same result here, negative root 2 over 8. So that's back to negative. So the 6 seconds, it slows down, it stops, and then the last 2 seconds, it's moving back, and it might end up where it started. But to answer the question, we can see, well, it's only moving in the positive direction between 2 and 6 seconds. So the interval is from 2 to 6. There we go. Okay, we have one more part. What is the acceleration at 2 seconds? Was the last question. Okay, well, for acceleration, we're going to need the derivative of velocity. Let me copy over the velocity so we can work with it. Go. For this next derivative, we'll call it a of t. We'll need chain rule again on the cosine pi t over 4. This negative pi over 4 is a constant multiple, so that's going to just carry along. And we say, okay, derivative of the cosine, negative sine, right? Pi t over 4. and then multiply by the pi t over 4 derivative again. So that's another pi over 4. There's our chain rule. And if we clean it all up, let's see, negatives cancel. We've got pi squared over 16 sine pi t over 4 as our acceleration. Okay. And we want to know acceleration at 2 seconds. What will we have here? Pi squared over 16 sine, plugging in 2 would give us pi over 2. Sine pi over 2, well, that's 1. So pi squared over 16. What would be the units here for acceleration? And it turns out it's meters per second squared. Meters per second per second. There you go. Pi squared over 16. Okay, let's stop with that one for this video. And I will see you guys for a couple more examples in a moment.